Okay, today we are going to solve quadratics for the square roots. To set this up, I want to go back to just simply finding the square root of a number. When we find the square root of a perfect square like 36, we said that it was 6 or negative 6, so we're going to say that's a plus or minus 6. So let's look at the first one we're going to have to solve. X squared equals 36. We're going to undo this. We're going to isolate the x by undoing the squared part. So the opposite of squaring a number is taking the square root. So I'm going to take the square root of the left side, take the square root of the right side. The square root of x squared is x. Now, the square root of 36, as we just mentioned right here, is plus or minus 6. So x is equal to plus or minus 6. Let's look at x squared equals 100. X squared is by itself, so I can isolate the x by taking the square root of both sides. Square root of x squared is x. Square root of 100 is plus or minus 10. X squared equals 144. The x squared is by itself. Square root both sides. X is equal to plus or minus 12. X squared is equal to 16. X squared is by itself. Square root of x squared is x. Square root of 16 is plus or minus 4. And the last one we're going to look at there is x squared is equal to negative 4. Take the square root, take the square root. This is x. That's taking the square root of a negative number. This has no real roots. So there really are no real solutions, but we're going to have a complex number or imaginary number here. So that's the same as x is equal to the square root of 4 times the square root of negative 1. X is equal to the square root of 4i. So we have x is equal to 2i. I guess that would actually be plus or minus 2i. That's my solution right there. There are no real roots, but if I wanted the complex root or the imaginary root, it would be plus or minus 2i.